Kolbes electrolysis or Kolbes electrolysis. This is electrolytic decarboxylation. Electrolysis of aqueous solution of sodium or potassium salts of carboxylic acid. Electrolysis of aqueous solution of sodium or potassium salts of carboxylic acid gives alkanes. Now let us see this reaction. RCOONA. 2 moles of RCONA, aqueous solution when subjected to electrolysis, you will get RrCO2 plus 2NaOH plus H2. Okay, again I am repeating. Electrolysis of aqueous solutions of sodium or potassium salts of carboxylic acids gives alkanes having twice the number of carbon atoms present in the alkyl group of carboxylic acid. This we have to remember carefully. So, electrolysis of aqueous solution of sodium or potassium salts of carboxylic acids gives alkanes having twice the number of carbon atoms present in the alkyl group of carboxylic acid. For example, let us take CH3COONA. When this compound is subjected to electrolytic decarboxylation, which is nothing but Kolbes electrolysis, what will I get? CH3CH3 plus 2CO2 plus 2NaOH plus H2. Okay, so what is happening here? We are getting a hydrocarbon, we are getting an alkane having twice the number of carbon atoms as that of carbon atoms present in the alkyl group of the carboxylic acid. This is nothing but Kolbes electrolysis or electrolytic decarboxylation. Here at anode, because it is electrolysis, at anode ethane will be obtained, means hydrocarbon gas will be liberated at anode and hydrogen gas will be liberated at cathode. Hydrocarbon will be liberated at anode and hydrogen will be liberated at cathode. Hydrocarbon as well as carbon dioxide will be liberated at anode and hydrogen gas will be liberated at